Okay, so what I want to talk about today is two things: water treatment plants, drinking water plants, wastewater plants, drinking water plants, and landfills. Um, so let's start with landfills. So landfills, when I was a kid, let's see if landfills, which are often called sanitary landfills, but when I was a kid, they were dumps, which is weird to think about. But literally old, stream valleys, quarries, steep roadsides, sinkholes, any kind of depression was a great place to get rid of your stuff. And so people would go out there with their truck and they would throw in old paint cans or old mattresses that had broken down or parts of cars or tire, just whatever you want to get rid of, you just threw it in there. And you didn't really think or care about what happened to it. What we know now, of course, and what many geologists knew back then, was that holes in the ground are very, very rarely isolated. They're connected to streams, to aquifers, and so forth. In some cases very quickly, in other cases more slowly. Classic example, and somebody in the class was reading about this. Might have been Laura in northeastern Iowa. So here's, I don't know what Iowa looks like. There's Iowa up in northeastern Iowa. That's north. There there's a whole area up there with the Mississippi River is running. Mississippi River is running right there, running this way. Very steep slopes and lots of limestone exposed at the surface, and so the land surface. Here's the river, or different rivers. Is actually, it's all this limestone. It's like Swiss cheese, and there's lots of sinkholes up at the top. And once water or anything gets into those sinkholes, it runs through these conduits and comes blasting out the bottom very, very quickly. Literally in a matter of minutes from the time a big rain can start, you can start seeing increases in the water coming out of springs down here. You can see increases in the amount of mud in the springs because it's being carried off of the soils on the upslopes. The amount of fertilizers and other products of agriculture. So anything that you throw in these sinkholes, you're basically contaminating the water system, including the streams and whatever else. Starting in 1976, you remember RCRA, the Resource Conservation and Recovery Act, that said basically you got to track things cradle to grave, and you can't just go throwing stuff in the dumps anymore. And so we began to monitor a lot about this. One of the big problems with landfills today is finding a place to put it. It's the siting of landfills, figuring out where they're going to go. There's an old acronym that's involved and that's used a lot in environmental issues. It's NIMBY, which you probably have heard of. It's not in my backyard. So everybody wants a wastewater treatment plant, but nobody wants one in their backyard. Everybody wants a sanitary landfill, but not in their backyard. So finding a place to put one is tricky, and it involves, generally, here's a map, there's north, you want to be close to a big road, close to a road so that you're not, a major road, so that you're not trucking down gravel roads all the time. You want to be far from if this is a stream, you don't want to be right next to a stream. You want to be away from, those are houses. You want to be away from populated areas. Generally, if the wind is blowing this way, you want to be upwind from populated area. Downwind. If the wind is blowing this way, you want to be downwind from populated areas so that you're not blowing the smell over other places, over people. And so, you might say, okay, here's a potential site. And then once you've just kind of done that generic assessment, then you go in and you start looking at the geology. And the geological analysis would involve looking at the topsoil, right, and the sediments. So in Iowa, we have lots of glacial till. So we've got limestone. Most of Iowa is underlain by limestone. And on top of that is this glacial till that we've talked so much about, which is, a mixture of clay and sand and whatever. And it's generally pretty low hydraulic conductivity. And the other nice thing about it is it's unconsolidated. It's not lithified. It's not turned into solid rock. So it's very easy to go in with a backhoe and dig out a big area that you can then use as the base of the landfill. One of the things that we always worry about, there are two main things that we worry about with aside from the aesthetics, things like noise and trash blowing around and smell and that sort of thing. But the two big things we care a lot about are the gases that are produced in a landfill. The biggest of which is methane, and the other is leachate. Leachate, and leachate is the liquid that drains from a landfill. So water hits the top of the landfill and soaks down through, and it runs through old banana peels, and it runs past pieces of wood and paper and plastic and bits of olive oil and pieces of an old engine block or something in there. And so all of the stuff that interacts in the water is considered leachate, and it's very smelly, and it's in some cases kind of nasty chemically. Not in modern landfills as much because we keep the nasty stuff out, but in the old days in particular, it's a real problem. So landfill designs involve this aesthetic consideration and then this scientific consideration, geological, geochemical configuration. Let's talk a little bit about that. Methane is produced. Methane, its chemical formula is CH4. It's produced by anaerobic decomposition of organic matter. Organic matter being anything from wood to banana peels to paper to anything, you name it. So if it's decomposed of anaerobically, meaning that there is no oxygen around, the bacteria that live in anaerobic or oxygen-free conditions generally give off as a byproduct of their metabolic processes, of their living, of their breathing. They give off this methane, right? Methane is flammable, and therefore it's dangerous. And it's a very, very potent greenhouse gas, high greenhouse gas. So it's about 25 times as powerful as a greenhouse gas as carbon dioxide. So one molecule of methane in the atmosphere does the same amount of warming as 25 molecules of carbon dioxide. Did I say that right? One molecule of methane is the same as 25 molecules of CO2, yeah. And it's produced like crazy in landfills because there's very little oxygen down there and there's a lot of organic matter. So what's often done is, once the landfill is being built, is there are pipes that go down and they are hooked up to vacuums, big suction pumps. And the idea is that any methane that's produced down here gets sucked out into these little pipes and hauled off, and it's either collected. In some cases, you can collect the methane and you can actually strip the water vapor out and then burn the methane. Or in some cases, they literally just burn it off on site. There's just a little flame right there, and they don't try to do anything with it other than get rid of it. The reason you want to do that, of course, is if this methane builds up and builds up and builds up over time and then starts to leak out, it can find a flame and cause a fire. So that's a big problem. The other thing you have to worry about, as I mentioned, is this leachate. And the way that we deal with leachate generally is we try to find land, like in Iowa, that's like till, that has a very low hydraulic conductivity. So if anything does leak out, if any leachate does make its way out of the landfill, it's going to move very, very slowly downward. But we don't even want it to get out of the landfill at all. So you can see this little thing that I drew here. If we zoom in on that, the way they're generally done now is you dig a pit, right? And then you bring in a bunch of clay, and you lay that down. Clay does two things. It's got a very low hydraulic conductivity, of course, but it's nice and soft, and so it protects what you're going to put on top of the clay from anything sharp that might be down here in the till or the bedrock or whatever it is that you're drilling it out of. Then you put this very, very strong, you roll it out in big rolls, this very, very strong, high density, like rubber liner. This is a liner. It's very, very strong, and it comes in big rolls, and they literally weld where one roll meets another roll. They literally weld the two together. They heat it up so much that it melts and it forms a seal. And this goes, all over here, right? And then you put something like maybe more clay or sand or something on top to protect the liner, and then you start putting the trash in. And you put the trash in, and every day they are mandated by law to, at the end of every day, to bring in a little bit of dirt and spray it on top of the trash they put down that day. The reason for that is it keeps the smell down. It keeps rats and other rodents from going in and digging through the trash all the time, which creates a big rodent problem and public health problem. And it stops any wind that's coming along from picking up bags and whatever and blowing them off. So that's called the daily cover. So they got to have a fair amount of dirt lying around for these things. And then you build them up, and what's interesting about landfills is they're constantly, because there's so much decomposing going on, they're constantly compacting under their own weight. And so landfills that, when they're done, they might sit up above the Earth's surface in a big mound. 20 years later, they've subsided a good deal. In any case, when the landfill is finally done, you put one of these big covers like you have underneath it on the top, and then you cover it with dirt and plant it with grass. And as you're driving down the highway, what you notice is a big round hill, usually with methane pipes coming out of it. But other than that, you'd have no idea that it's just a big junk pile underneath. Now, in order to keep these things from filling up too fast, because it is very expensive to site one and to create one, the companies that run landfills often provide financial incentives, right? So if you or there are laws. Either way, you are not allowed, for example, to put electronics into landfills. Electronics are usually, when you go to the landfill, you set the old TVs and the microwaves and the refrigerators and those things off to the side so that they don't go into the landfill, and the electronics are recycled. There are things like organic waste, like wood waste from construction sites and so forth, is often chopped up and mulched, which can then be put on farmers' fields or in people's gardens. And the plastic is pulled out, and they make sure that things like dangerous chemicals like paints and oils and solvents and those sorts of things are also for free, are also recycled on site, so that you don't pay any price for putting it in the landfill, right? If you had to pay money to put paints and oils in the landfill, then people would just hide it, in which case you'd get all these nasty chemicals in your landfill. So you bring it there, and for free, you just drop it off in another site, and they take care of it for you. So anyway, that's a landfill. Now, the only other thing you have to worry about with landfills is the water table. That's the other big consideration. In places like Florida, where the ground is very flat and you're very low in elevation, you have water tables. Well, let's do two situations here. So here's let's say Nevada, which is a high elevation and dry state, high and dry, and in which case you got the water table way down here. No problem. We don't have to worry about anything. But in a place like Florida, where it's low and wet, you can have something that looks like this, where the water table is literally intersecting the landfill. And that's a problem, because if the water is intersecting the landfill, it's going to be under pressure, it's going to be forcing its way through the liner and into the landfill, in which case you're creating more leachate. and you want to minimize the amount of leachate. So what's done sometimes is they literally will install pumping wells on either side of the landfill. They'll pump the water out, and they'll create these, as you remember, these cones of depression, so that the water table literally is drawn down like this. I'm not doing a very good job here, but something like that. That's supposed to be the sort of intersection of the two cones of depression here. And so by pumping the water out, you lower the water table below the bottom of the landfill, and as a result, you don't have to worry about the leachate. Of course, as soon as you stop pumping, the water level goes back up, but for the time being, that's what you do. All right, so that's that, and when we come back in a second, we'll talk about wastewater and drinking water treatment plants.